Hey there, future innovators. I have a question for you, and I want you to really think about this. How many times have you used artificial intelligence today? Did you say 0? Maybe 1 or 2 times? Well, let me blow your mind. If you woke up to your phone's alarm, that's AI optimizing your sleep cycle. If you asked Siri or Google something, that's AI understanding your voice. If you opened TikTok and saw videos perfectly matched to your interests, that's AI learning what you love. If you used Snapchat filters that put dog ears on your face, that's AI recognizing where your face is and tracking it in real time. In fact, if you're a typical teenager or adult, you've probably interacted with AI over 50 times before lunch today. 50 times, and most of us have no idea it's even happening. But what's absolutely incredible, and why. I am so excited to share this with you today. Everything you just experienced, all of this magic technology started as a wild dream in the minds of a few scientists just 70 years ago. That's right, your grandparents were alive when the very first person said, "What if we could make machines think like humans?" And get this, some of those original dreamers thought they could solve the entire puzzle of artificial intelligence in just one summer. One summer, they were a bit optimistic, as you'll see, but their failed summer project eventually created the technology that powers your phone, recommends your Netflix shows, helps doctors detect cancer, and might even drive your car someday. Today, we're going on an incredible journey together. We're going to travel back in time to meet the brilliant minds who started this revolution. We'll witness the moments when computers first beat humans at chess, when machines learned to see and recognize faces, and when AI started writing poetry and creating art that rivals human creativity. But most importantly, and here you need to stick around for every single minute of this video, I am going to show you exactly how you can become part of this story. Whether you're 12 years old or 50, whether you love math or hate it, whether you can code or have never touched a programming language, by the end of this video you'll have a clear roadmap to start your own AI adventure. So here's what we're covering today. First, we'll dive deep into the fascinating history, and I mean really dive deep. You'll learn about the secret 1956 conference where AI was born. Why brilliant scientists got so excited they thought they'd solve everything in weeks. And why AI died twice before exploding into what we see today. Trust me, this story has more plot twists than your favorite Netflix series. Then, we'll explore how AI is secretly running our world right now. We'll peek behind the curtain of your favorite apps, discover how AI is revolutionizing medicine and might save millions of lives. And yes, we'll tackle the big scary questions too. Will robots take our jobs? How do we keep AI fair and safe? I'll give you the real, honest answers. And finally, this is the part I am most excited about. I'll break down the exact steps to start your AI journey. No matter what your background is, we'll cover the free courses that will get you started, the simple projects you can build this weekend, and the career paths that are wide open right now in the AI field. But before we jump in, I want to challenge you to something. As we go through this journey, I want you to think about one problem in your life, your school, your community, or the world that really bothers you. Got one? Good. Keep that problem in mind, because by the end of this video, you'll understand how AI could help solve it, and more importantly, how you could be the one to build that solution. Ready? Let's start our time machine and go back to where it all began. Picture this. It's 1950, and the world looks very different. There's no internet, no smartphones, no computers in homes. The most advanced computer most people know is a calculator the size of a desk. But in a small office in England, a brilliant mathematician named Alan Turing is asking a question that will change everything. Can machines think? Now, this might sound simple to us today. Of course, machines can think, right? Your phone thinks, your computer thinks. But in 1950, this was like asking, can we travel to Mars? It seemed completely impossible. Turing was fascinated by this idea. He created what we now call the Turing test. And it's beautifully simple. Here's how it works. Imagine you're texting with someone, but you can't see them. You ask questions, they respond. If you can't tell whether you're talking to a human or a machine, then that machine has passed the Turing test. Think about this. Have you ever chatted with customer service online and wondered if you were talking to a human or a bot? That uncertainty? That's exactly what Turing was talking about. But here's where it gets really interesting. Turing wasn't just daydreaming. He was working on some of the first real computers. These machines were massive, literally the size of entire rooms, and they could barely do basic math. But Turing saw something nobody else did. He realized that if machines could process information and follow rules, maybe they could eventually mimic human thinking. Around the same time, other brilliant minds were having similar thoughts. There was John von Neumann, who designed computer architectures we still use today. There was Claude Shannon, who figured out how to make machines understand information. He basically invented the language computers use to talk to each other. And then there was Warren McCulloch and Walter Pitts, who had a crazy idea. What if we could build artificial versions of brain cells? They created the first mathematical model of what we call a neuron, the basic building block of your brain. Let me explain neurons in the simplest way possible. Your brain has about 86 billion neurons. They read like tiny switches that pass messages to each other. When you see a cute dog, thousands of neurons fire in a pattern that says cute dog. When you smell pizza, different neurons create a pizza pattern. McCulloch and Pitts thought, what if we could build artificial neurons, mathematical switches that could pass messages and create patterns? This was the birth of what we now call artificial neural networks. Now, here's the mind-blowing part. That same basic idea from 1943 is what powers ChatGPT, facial recognition, and voice assistants today. We'll dive deeper into how this works later, but just remember, every time you use Shazam to identify a song, you're using a descendant of McCulloch and Pitts's artificial neuron idea. But having ideas is one thing. Turning them into reality is another. These early pioneers had brilliant concepts. But the computers of the 1940s and 1950s were barely powerful enough to do basic calculations, let alone think. That's when something amazing happened. A young professor named John McCarthy had an idea. What if we brought together the smartest people in the world for one summer and tried to solve this artificial intelligence puzzle once and for all? This decision led to a conference that would officially launch the AI revolution, and set expectations so high that when reality hit, it nearly killed AI research for decades. But it also planted the seeds for every piece of AI technology you use today. In our next section, we're going to visit that legendary summer of 1956. Meet the people who coined the term artificial intelligence, and discover how their wildly optimistic predictions both inspired and nearly destroyed the field they created. You won't believe what they thought they could accomplish in just 8 weeks. Welcome back, AI explorers. Let us step into our time machine and travel to the summer of 1956, specifically to Dartmouth College in New Hampshire, where one of the most important meetings in human history was about to take place. Picture this. It's a beautiful summer day, and 10 of the world's smartest mathematicians and computer scientists are gathering for what they're recalling the Dartmouth Summer Research Project on Artificial Intelligence. This is literally the first time anyone has ever used the phrase artificial intelligence officially. The leader of this group is John McCarthy. Imagine a brilliant professor with the confidence to believe he can solve one of humanity's biggest puzzles in just 8 weeks. His proposal to get funding was beautifully bold. We think that significant advances can be made in one or more of these problems. If a carefully selected group works on it together for a summer, these weren't just random smart people. This was like assembling the Avengers of mathematics. You had Marvin Minsky, who would later become known as the father of AI, Claude Shannon, the genius who invented information theory. Nathaniel Rochester from IBM, who was working on the most advanced computers of the time, and several other brilliant minds, all convinced they were about to change the world. Now, imagine you're in their shoes. You genuinely believe that in just 2 months, you can create machines that can think, learn, and solve problems like humans. How would you feel? Excited? Nervous? Ready to change everything? Well, that's exactly how they felt. And you know what? They did change everything. Just not in the way they expected. Here's what actually happened that summer. They made some progress, had fascinating discussions, and laid important groundwork. But did they solve artificial intelligence? Not even close. It turns out that making machines think like humans is slightly more complicated than they imagined. But here's why this failure was actually the most successful failure in history. It officially launched the field of AI research, attracted brilliant minds from around the world, and most importantly, it gave us the term artificial intelligence that we still use today. Despite not solving everything in one summer, these pioneers and others inspired by them started creating some absolutely amazing programs. The first real AI program was called The Logic Theorist, created by Alan Turing and Herbert Simon in 1956. This program could prove mathematical theorems. Basically, it could solve logic puzzles that would challenge smart humans. When they presented it, they said, "We have invented a thinking machine." Let me explain what this means. Imagine you have a puzzle. If all dogs are animals, and all animals need food, then all dogs need food. That's logical reasoning, right? The logic theorist could solve puzzles like this automatically. It was the first time a machine had done something that looked like human reasoning. Then, in 1966, a computer scientist named Joseph Weizenbaum created something called ELIZA. And this will blow your mind. ELIZA was basically the first chatbot, and it pretended to be a therapist. Here's how it worked. You'd type something like, "I'm feeling sad," and ELIZA would respond with something like, "Why are you feeling sad?" Or, "Tell me more about feeling sad." People got so emotionally attached to ELIZA that Weizenbaum himself got scared. He realized people might start preferring to talk to machines instead of humans. Sound familiar? ELIZA is basically the great-grandmother of Siri, Alexa, and ChatGPT. Every time you have a conversation with an AI assistant, you're experiencing an evolved version of what ELIZA started in 1966. But then, something disappointing happened. By the 1970s, the initial excitement started wearing off. The early AI programs were impressive, but they couldn't handle real-world complexity. An AI winter is exactly what it sounds like. A period when interest, funding, and progress in AI research basically froze up. It's like when everyone gets super excited about a new video game, but then realizes it's not as amazing as the trailers made it look, so they move on to something else. Here's what went wrong. The early AI programs were great at solving specific puzzles, but terrible at dealing with the messy, complicated real world. A chess program couldn't recognize a face. A math theorem prover couldn't understand a simple sentence. And computers were still incredibly slow and expensive. Plus, some researchers made promises they couldn't keep. They said things like machines will be capable, within 20 years, of doing any work a man can do. When 20 years passed and we didn't have robot butlers and AI doctors, people got disappointed. But here's the important lesson. And this applies to your life too. Just because something takes longer than expected doesn't mean it's impossible. Sometimes the most amazing breakthroughs require decades of patient work, failed experiments, and people who refuse to give up. AI research didn't die completely. Though in the 1980s, there was a brief resurgence with something called expert systems. An expert system was like having a human expert's knowledge stored in a computer. Imagine taking everything a doctor knows about diagnosing diseases and programming it into a computer. The computer could then help other doctors by asking the right questions and suggesting possible diagnoses. Think of it like this. You know how your parents might ask you a series of questions when you're sick. Does your throat hurt? Do you have a fever? Are you nauseous? Based on your answers, they might say, sounds like you have the flu. Expert systems worked the same way, but with much more complex medical knowledge. These systems actually worked pretty well for specific tasks. There were expert systems for medical diagnosis, mineral exploration, and computer configuration. Some companies made millions of dollars from them. But here's the problem. Expert systems were incredibly brittle. That means they only worked for very specific situations. If you asked them something slightly different from what they were programmed for, they'd give completely wrong answers. Plus, they required human experts to spend months or years teaching the computer everything they knew. It was incredibly expensive and time-consuming. By the late 1980s, people realized that expert systems weren't going to lead to true artificial intelligence. This led to the second AI winter, which lasted through most of the 1990s. But while many people gave up on AI, a few persistent researchers kept working. And three things were quietly happening that would eventually lead to the AI explosion we see today. First, computers were getting faster and cheaper every year. Remember Moore's law? It says that computer processing power doubles every 2 years. By the 1990s, computers were finally becoming powerful enough to handle more complex AI tasks. Second, the internet was creating massive amounts of data. And here's something crucial about AI. Most modern AI systems learn from examples, not rules. The more examples you can show them, the smarter they get. Third, researchers were rediscovering and improving those artificial neural networks we talked about earlier. They figured out better ways to train them and make them work for practical problems. All of these factors came together in 1997 for one of the most dramatic moments in AI history. IBM's Deep Blue computer defeated world chess champion Garry Kasparov in a 6-game match watched by millions of people worldwide. This wasn't just about chess. For decades, people had said that machines could never beat humans at chess, because chess requires intuition, creativity, and strategic thinking. Things only humans could do. When Deep Blue won, it proved that machines could master tasks that we thought required human-level intelligence. But Deep Blue was still old-school AI. It used brute force computation to analyze millions of possible chess moves. The real revolution was just beginning. In our next section, we're going to explore how AI learned to truly learn, how it started recognizing faces, understanding speech, and eventually writing essays and creating art that rivals human creativity. Get ready, because we're about to enter the era where AI stops being a laboratory curiosity and becomes the invisible force powering your daily life. We'll discover how machine learning works, why your phone got so good at understanding your voice, and how AI went from playing chess to creating TikTok videos. Welcome to the final part of our incredible AI journey. We've traveled from the dreamers of the 1950s through the ups and downs of early AI research. Now we're entering the era that created the AI-powered world you live in today. Around the year 2000, something revolutionary happened in AI research. Instead of trying to program computers with rules and expert knowledge, researchers started asking a different question. What if we could teach computers to learn from examples, just like humans do? This shift created what we call machine learning. And I want you to understand exactly what this means, because it is powering almost every AI application you use today. Let's say you want to teach a computer to recognize cats in photos. The old approach would be to program rules. Cats have pointy ears, whiskers, 4 legs, fur, ... But what about hairless cats? What about cats sitting down so you can't see all 4 legs? You'd need thousands of rules, and there would always be exceptions. Machine learning takes a completely different approach. Instead of programming rules, you show the computer thousands of photos labeled cat, and thousands of photos labeled not cat. The computer analyzes all these examples and figures out the patterns on its own. Think about how you learned to recognize cats as a child. Did your parents give you a list of rules? No, they pointed at cats and said cat until you figured out what makes a cat a cat. Machine learning works the same way. It's like teaching a computer through examples instead of rules. This approach only became possible when 3 things happened simultaneously. First, the internet created massive amounts of labeled data. Every time you tag a photo on Facebook, rate a movie on Netflix, or correct Siri's speech recognition, you're providing training examples for machine learning systems. Second, computers became powerful enough to analyze millions of examples. Remember those artificial neurons from the 1940s? By the 2000s, computers could simulate networks with thousands of artificial neurons working together. Third, researchers developed better algorithms, the mathematical recipes that help computers learn from examples effectively. The real breakthrough came when researchers figured out how to create deep neural networks. Networks with many layers of artificial neurons working together. Imagine you're trying to recognize a face in a photo. The first layer of neurons might detect simple things like edges and shapes. The second layer combines these 2 recognized features like eyes, noses, and mouths. The third layer puts these together to identify specific faces. Each layer builds on the previous one to understand more complex patterns. This is called deep learning, because the networks have many deep layers, like a many-story building, where each floor specializes in understanding different aspects of the problem. In 2012, something happened that changed everything. There's a competition called ImagiNet, where research teams compete to build the best image recognition system. For years, the accuracy had been improving slowly. Then, a team using deep learning achieved a massive breakthrough. They improved accuracy by over 10% in a single year. Suddenly, computers could recognize objects in photos better than many humans. This didn't just improve photo recognition. It proved that deep learning could solve problems that had stumped AI researchers for decades. Within a few years, we had speech recognition that actually worked. Hello, Siri. Language translation that made sense. recommendation systems that knew your preferences better than your friends, and yes, filters that could track your face and put virtual dog ears on it. Now let's talk about how AI is transforming the world right now, including ways that might surprise you. In medicine, AI is detecting diseases earlier and more accurately than human doctors in many cases. AI systems can spot skin cancer in photos, detect diabetic eye disease, and even predict heart attacks before they happen by analyzing patterns in medical scans. Here's how medical AI works. Doctors feed thousands of medical scans into a deep learning system. Along with diagnoses from human experts, the AI learns to recognize patterns that indicate disease, sometimes patterns too subtle for human eyes to notice. Self-driving cars use multiple AI systems working together. Computer vision recognizes pedestrians, traffic signs, and other cars. Prediction algorithms guess what other drivers might do. Planning systems decide the safest route and speed. Your daily apps are powered by AI too. Netflix uses AI to recommend shows you'll love. Google Maps uses AI to find the fastest route and predict traffic. Spotify's Discover weekly playlist is created by AI analyzing your music preferences. Even your email spam filter uses machine learning to identify unwanted messages. Recently, AI has started creating original content. Systems like GPT can write essays, stories, and even poetry. DALL-E and Midjourney can create original artwork from text descriptions. AI can compose music, generate videos, and even write code. But with great power comes great responsibility. AI isn't perfect, and we need to talk about the challenges honestly. AI systems can inherit human biases from their training data. If an AI system is trained on biased examples, it will make biased decisions. For instance, if a hiring AI is trained on historical data where certain groups were unfairly excluded, it might continue that discrimination. Imagine an AI system trained to recognize professional photos, using mostly photos of men in business suits. It might incorrectly assume that women in professional attire are less professional looking. This isn't because the AI is evil. It's because it learned from biased examples. AI's ability to recognize faces, analyze behavior, and process personal data raises important privacy questions. How much should companies know about us? How do we balance convenience with privacy? Yes, AI will automate some jobs, but history shows us that technological progress usually creates more jobs than it eliminates. They readjust different kinds of jobs. The key is preparing for this change by learning new skills. Now comes the exciting part: how you can become part of this AI revolution. First, don't panic about math. You don't need to be a math genius to work with it. You need basic algebra and statistics. Think understanding, averages, and percentages level math, not advanced calculus. Programming is helpful but not always required. Python is the most popular language for AI, and it's designed to be beginner-friendly. If you can follow a recipe, you can learn Python. Start with these free resources. AI for Everyone by Andrew Ng on Coursera. No programming required. Khan Academy for math refreshers. Python.org /s beginner tutorial. YouTube channels like 3B, Luean Brown for visual explanations begin with simple projects. Build a chatbot using available tools. Create a basic image classifier. Analyze your own data, music listening habits, exercise patterns. Try AI art generation tools like DALL-E or Midjourney. Join communities. Reddits are machine learning for news and discussions. Local coding meetups, online courses with discussion forums. GitHub to share your projects. AI careers aren't just for programmers. AI ethics specialists ensure AI is fair and safe. Data scientists analyze patterns in data. Product managers design AI-powered products. Technical writers explain AI to non-experts. Sales engineers help companies adopt AI solutions. Remember that problem I asked you to think about at the beginning. The one that bothers you about your life, school, community, or the world. AI could be the tool that helps you solve it. Climate change, healthcare access, education, inequality, accessibility for disabled individuals. AI is already being used to tackle all of these challenges. And the next breakthrough might come from someone watching this video right now. Here's what's amazing about this moment in history. AI tools are becoming accessible to everyone. You don't need a PhD or millions of dollars to start experimenting with AI. Many powerful AI tools are free or low cost, and the learning resources are available to anyone with internet access. Before you click away from this video, do this. 1. Bookmark one learning resource I mentioned. 2. Think of one simple AI project you could start this week. 3. Join one AI community online. 4. Tell someone about what you learned today. 70 years ago, a small group of researchers dreamed of thinking machines. They failed to achieve their goal in one summer, but their persistence created the foundation for everything we use today. Today, AI isn't just in research labs, it's in your pocket, in your apps, and increasingly, it's becoming a tool that anyone can use to solve problems and create amazing things. The question isn't whether AI will shape the future. It is whether you will be someone who helps shape AI. The next chapter of this incredible story is waiting to be written, and you have the opportunity to be one of its authors. The AI revolution isn't just about the technology. It's about human creativity, curiosity, and the desire to solve problems and make the world better. And those qualities, those are exactly what you bring to the table. So what are you waiting for? Your AI journey starts now. If this video inspired you, hit that subscribe button and share it with someone who needs to see it. Drop a comment telling us what AI application you're most excited to build. And remember, the future belongs to those curious enough to learn and brave enough to try. Thanks for joining me on this incredible journey through the history and future of artificial intelligence. Now go out there and make some AI magic happen.